So when we're trying to consider which weak acid is a stronger weak acid, we need to compare the Ka values for each acid. So in this problem, we have phenol with a Ka value of 1.3 times 10 to the minus 10. And we want to know if phenol is a stronger or weaker acid than water at 25 degrees Celsius. We know for water, the Kw value, which is what we're going to compare to in this case, is 1 times 10 to the minus 14. So because the Ka at 1.3 times 10 to the minus 10 is greater than Kw, that means that phenol is a stronger acid. Likewise, when we're comparing the Kas for phenol and hypochlorous acid, we would the weak acid that is stronger is going to have the larger Ka. So hypochlorous acid has a 3 times 10 to the minus 10 Ka. And so if we compare that to phenol, this is larger, so hypochlorous acid is a stronger acid. If we were to compare the basicity of the conjugate base of phenol to that of hypochlorous acid, we could determine which is stronger. So the conjugate base, in this case, let's just think about a generic conjugate base, A-. When we put that in water, our equilibrium is going to be with HA and OH-. So we want to know which of these conjugates, the conjugate base of phenol or the conjugate base of hypochlorous acid, is going to produce products the most in this equilibrium. Because we're working with a base, we'll have Kb values associated with these. We know the Ka values for phenol and hypochlorous acid, so we could calculate the Kb values using the expression Kw equals Ka times Kb and solve for Kb. And then we could compare those. The larger Kb value will be the stronger base. However, one other way you can approach this is knowing that the weaker acid is going to have a stronger base, conjugate base. And that's because the conjugate base is more likely to pick up a proton to reform the acid in OH-. Okay, so for this question, the weaker acid is phenol, okay, with 1.3 times 10 to the minus 10 Ka. So its conjugate base is stronger than hypochlorous acid.